And we are recording. Hello, everybody. Tonight is the 24th of September. This is Dallas Personal Robotics Group Builders Night, virtual, online, whatever you want to call it. We're going to do the usual in a few moments and go around the table, probably mostly open mic night tonight. Before that, I'd like to call attention to one fun-looking thing coming up this Saturday. We have dual presentations on troubleshooting with JTAG and ROS 2 on a Raspberry Pi Zero 2W. So be there in person at the Dallas Makerspace, or I presume online as well. And if you can't make it, we'll have a recording. Aside from that, we are actively working towards a contest coming up in the end of November, Robo Columbus. So I encourage interested parties to look into that and see if you want to show up just to observe or to participate would be great. Guys, is there anything else I should raise before we jump right in?
When does that start? Is it 10 a.m.? The meeting?
The meeting this coming Saturday.
Yeah, 10 a.m. Yeah.
Our new meeting time is 10. And we've been getting pizza lately, I think, haven't we, for people in person?
We have.
Yep, but white pizza only.
Oh, no.
Just for Doug.
Fair enough. All right, then. Well, so the queue we have tonight is pretty short to start with, but I'm sure we'll go somewhere. Ray has some thoughts to follow on. We had a little pre-meeting discussion, so maybe you could refresh that, Ray, and then carry us on with it. And then Kareem has a couple of maybe bits of a tale of woe, and then unless someone else raises their hand now, we'll jump straight to open mic.
Yeah, I can update on my MicroPython trials for a few minutes.
Good. Ray, Kareem, then Tom. So Ray.
Okay.
So
I
you're
found something, so I might
John,
show
okay.
something.
Good. Okay.
Okay.
So just a brief refresher of the topic for people watching the recording, and then carry on.
Okay. I am working on a GPS RTK solution. They're SparkFun modules. They are the it's the Neo M8P-2. And I've got, this is all kind of on my desk here. I wonder if I could get my phone and kind of show it, because all my USB ports are used right now for powering stuff. I wonder if I could do that. I'll try that here real quick. Come on, phone. DPRG.org. Okay, where's the sign in? Yeah, I think I scrolled right past it. Oh, there it is. Okay. Oh, I may have to mute my mic here.
Aha, so we need to pin your screen.
Looks like you're muted on both, Ray.
Okay, Ray, you're still muted. There you go. That looks better.
Okay. Let's see if I can get that in there. Okay, so here is the GPS unit. That is the radio link. That's a cutie pie and a small display. Let's see if I can get that in focus. Yeah, come on. Anyway, it's showing latitude, longitude, and the fix, which right now is the number 3. And I'll be very happy when the little green LED on the module, starts blinking, because that's indicating that you have an RTK solution. My antennas are just sitting over on that window ledge there, so this isn't a very good setup to try to do this. This is the base, which has the same module, the same radio link, and this is another board that the cutie pie is on. So right now I'm trying to send RTCM3 data over the link, which that brown button, or not brown button, or red LED, I guess it is blinking, says every time it blinks, that's transmitting the data. And this guy, every time it blinks, it's kind of faint, but the little red blink there says it's receiving that data. And when it actually gets into RTK mode, the fix should go to either 4 or 5 on the display. Yeah, I thought that came in better. Anyway, so it's kind of a temporary setup. The base unit will go in a box and will be battery powered. And I'll just set the antenna on a tripod, and then this will go on the rover. And well, not this hardware. The module will go back on the rover. I pulled it off, and I'll have the radio link at this point, whereas before I didn't have that. So anyway, that's what I'm trying to get working. I'm gonna sign off on the phone.
And I think the phone was your mic, so you'll need to turn your laptop mic back on. And then, are you stuck, Ray? You have questions you're exploring, or?
Well, at this point, they say that your antenna is supposed to have clear view of the sky, and right now it has clear view of the window frame and a pretty good sized tree right outside the window. So I'm don't want to go out there and get all eaten up by chiggers and mosquitoes and everything else. And so I thought I would get this working as best I could inside. But they said that, that's one of the things you must do, especially for the base, is get clear view of the sky, and it'll work, much better, I think, at this point. That's kind of the next step, to see if I've set everything up, everything up right on the base side and the rover side. And hopefully, like I said, the little RTK light will start blinking, indicating that I'm actually going into RTK mode. So right now it's stuck at a fixed level of 3, which is 3D, so I can do latitude, longitude, and altitude. And that's about it.
So Ray, in order to implement this, you need what? 2 of those modules?
Yeah. One is the base, and
anything else?
The other on the rover.
Is there anything else you have to have?
I've got to have the radio, some sort of radio link between the two. You can use, I don't know, are Zigbees now called XBs?
Okay, so basically a digital data link,
Yeah.
presumably not high speed.
No, I mean, this, it has a serial input at, I'm running it at 57.6. The module's default serial port baud rate is 9600. So, it can be very slow.
Yeah. Do you
And
need separate antennas, or do antennas come with it?
no, you have to buy pretty much everything by itself. So,
Okay, so the antennas are extra.
yeah. An M8P solution is over 500. The ZF9, I think, may be closer to 600 or 700.
I just looked at the Adafruit pricing while you were talking, and it's a lot less than I thought.
Oh yeah, for just a module. I think I have one of their little modules that I made a temporary GPS setup. It's pretty small. Yeah, versus what is it, $20 or $30 for non RTK versus what all this costs.
Yeah, I'm seeing about $100 Canadian per GPS module. So 2 of those plus 2 antennas plus the radio link. Probably, from my perspective, probably still under $300.
Yeah, I think SparkFun reduced the cost of the modules. I think they're having a heck of a sale on it right now. Probably means they're going to discontinue it and not do any support for it, surely. I think they're on it. It's got like a 10 in the number. It's the successor.
Oh yeah.
To this,
Yeah, Ray. That's usually how it works. I find something cool I like. I see it on sale. I buy, I don't know, a couple to try it out. The next thing I know, ghost.
Yeah. Anybody want an Edison from Intel?
Yeah.
Yeah. There you go.
I got a mess up.
Or any other product from Intel, for that matter.
Yeah.
Anyway, so at the time, I thought an inch resolution would be good enough. And if it, worked anywhere near close to that versus regular, well, I don't know. I think they've made claims that said it could work as good as, a little over a meter, but there's no guarantees with just regular GNSS that you'll get that kind of resolution. So, and these seem pretty stable. I mean, you can kind of look at the readings and, the last maybe 2 digits are changing a little bit, but it's still not, RTK level. So hopefully I can get it all working and guide the little robot a little better. Yeah, I was looking at my Robo Magellan code, I guess. Anyway, I added, it's one of those things, never try to make software modifications the day of the contest. You will always screw something else up, forget something. It's a disaster. Anyway, so I added additional waypoints because of where the one cone was. It went through on Steve's property, the Texas thicket area, vines and prickers and poison ivy and everything else. And I forgot to follow that. I had basically, I only looked at the first 3 in the list, even though I had 7. So, I was screwed from the start. It got to the first cone, and after that, it lost its way. And I was like, God, I don't know what's going on with this thing. And then I looked at it, and it's like, forgot to follow through on all the modifications to add additional waypoints. So I'm going to try GPS RTK. I'm going to try to fix all my software issues, and I'm going to try to put an improved bumper on the thing that if it does get tangled in the weeds, the ends of it will hinge forward, and hopefully, without the hinging right now, just a small stalk could get in behind or between the bumper and the frame. And if I back up, it's just going to pull on the bumper. You know, the bumper is basically going to hold it in place. So I'm thinking if I hinge the ends of it in that so that it can't snag, you know, a stalk or a weed or something, that, you know, I can actually get out of situations where if I do go into the bushes, that I can get out of the bushes. So anyway, hopefully all those improvements will make a functioning robot again. So anyway, that's what I've been working on.
All right. You've
Yep.
always managed to get a couple of points. So, I mean, you're doing, I mean, you know, I actually, in one of my competitions, I found I had put in the totally wrong program. So, I mean, you did better than that. Just doing 3 instead of 7, you know, that's minor problem.
Yeah. I couldn't believe it. I looked at it and it's like, oh God, it's no wonder this thing didn't work. So anyway, so little baby steps, you know, no big drastic complete changes of, you know, drive or motor type or any of those things. So
Now, I have one
hopefully.
question that maybe you or Kareem can answer. For a test where you are right now, where you've got a static location, you know, I have set up similar things here in my little workspace. And, you know, what you see is if you let it go for like 24 or 48 hours, you can watch the spot. You know, it'll do 90% of the time. It's pretty good. But every once in a while, you know, it's in my neighbor's bathroom. So the question I have is, have you just ran it sitting there to see if it's, you know, what your spatial distribution is? I mean, if you got like a Gaussian distribution around the center point without any outliers, that's all you need. I mean, you'd be better off than most GPSs. Because like I say, most GPSs do great most of the time.
Yeah.
And then they just wander off.
Mm-hmm. Yeah.
That depends
I
a lot
haven't,
on your the spread of your data points.
Mhm.
say that again.
Right. It can still be a nice Gaussian distribution, but you can have a really wide spread of your data points. So, you know, over space so it doesn't help that it's Gaussian. Like
No, I'm just saying it with a normal GPS, it won't be.
I'm saying that works for a base station, that might work, but not for a rover.
So he's collecting data on both on his base station and his rover setup. Why couldn't he just map that data? I mean, he's got to go into a display. He might as well, you know, just send it to a PC and just, you know, there's programs all over the place where you can just collect data and then run it into and see what it looks like. I'm just saying that, you know, I know that when I've done a GPS, it usually, like I say, it does good most of the time, but, you know, there'll be some like, you know, just like, what's it doing? It's just jaunting off into the wilderness. You know, and then it'll come back, and then the next time it jaunts off, it might be in the other direction. So I'm just saying, and I'm sure it has something to do with the satellites, but I'm saying if you've got one that's just sitting there pinging in the same spot all the time, that would be, I think, a good indication that something's working.
Ray, what is your GPS data rate? How fast are you getting new points?
It's just 1 hertz. I think with these modules, I want to say you can get it up to like 4 hertz.
And in terms of your navigation requirements, what data rates do you need?
1 second is fine. I mean, it doesn't travel.
I'm
that
thinking in
fast
terms
or that
of
far.
with a bit of data analysis and an awareness of what your navigation requirements are, you could fairly quickly establish what sort of filtering you may want to do in order to minimize any of the deviations you're seeing that you're uncomfortable with.
Yep.
Now, I think the answer to do it right is a Kalman filter, but it's not simple, and I know I'm struggling with it right now, but that's the answer to your question, Tom, is you have a Kalman filter. And so like when it goes off into the weeds, its Kalman gain just drops. So your other sensors pick up the slack.
Well, I think I'm not certain of all what goes on the base station, but the survey in mode is supposed to, because it is stationary, you once you set it up, you're not supposed to move it.
Mhm.
And it's somehow creating correction data that it sends off to the rover that allows it to, so I'm not certain what statistics are going on and how they're improving it. And it is, I just like to use it. I don't necessarily need to know all the.
So gather some data and plot it on 2D and see what you get.
Yeah. Yep.
Then you'll know whether you need to worry about it.
Yep. So what is that Kareem you're showing
It's
us?
me. Yeah.
Yeah.
So this was some measurements that I took over time. So this was a 30-minute scan. This was
Yep.
using the ZF9P, but without any correction.
Okay.
All right. So it was, what mode was it? Oh, so to give you a sense of scale, this box right here, the square is about 12 feet by 12 feet.
Okay.
All right. So, and then so here I had RTK correction going on, but so this was 3D fixed.
Yeah.
What is hard? So again, it's 30 minutes, so it's hard to tell from this cloud up here. But the fact that it's so like there's no lines at all means that it was like jumping around all over the place. Here it tends to wander in these like little lines that are going on, right? But it was a really bad antenna location. So it was like under the eaves, it was occluded by the chimney. So there was just it was basically what you're doing with the right in the window.
Yeah.
But it wasn't in the window. I started it outside in order to get the initial fix, and then I brought the antenna inside and put it on a table. But there are some windows that it could peek out, but it was pretty bad.
Yeah.
So here it is with a fix.
Oh wow! So that's that little green dot.
Yeah, that one. It's basically 1 pixel. Like, but that was the minimum resolution that the mapping software would give me.
Wow.
So it could have been somewhere inside that pixel. So yeah. So that was nice. And again, this was only half a minute, right? So, but they were all right on top of each other. And then this was me walking the antenna around there's a little table right here.
Yep.
You can't really make out, but this is a satellite image, and I was just holding the antenna in my hand and walking it around that. It's probably a 4-foot table, something like that.
So that's the rover setup that you were walking around.
Yeah. There was no robot. I was just holding the antenna. And my laptop was still inside, but I was just on a long cable walking it around. So again, each of these fixes is that's as small as this shows. So I don't, and I wasn't like on a track or anything where I was trying to be super precise.
Yep.
Let's see what happened here.
How are you plotting this
So
data?
this is much further out. So there's now I'm totally blanking on it. There's a standard utility that you get from uBlocks, their software. I forget what it's called. It's like the standard thing you use when you spin up.
U-block center, Q center.
Yeah, U center. Yeah, and you can turn on satellite imaging to help track.
Yep.
So this is zoomed way out, and I don't remember what were the stats on this one. Oh, this is when I pulled it back inside and let it run for like hours and hours.
Oh, okay.
So
Pulled
this
the
was
base
this
back
was this
inside?
was without a fix. This was totally without a fix,
Yeah.
right? But it was just like all over the place, right? Because this is
Yep.
way zoomed out from those other images that we were looking at. Now you can see the neighbor's properties and such. So
Yeah.
so it can vary a lot depending on the quality of the fix. So you need to be tracking that quality of the fix, and the RTK, the fixed is what you really want.
Right.
So I only brought this up because it was I guess the questions that Doug was asking about
Okay.
variability.
Yeah. Well, the ones where you have,
And
you
there's
know,
a whole document here. This is like documenting my initial learning and run into RTK. So this is available.
yeah.
I posted it before in the Discord.
Oh, you did. Okay. If I can't find it there, how else would I find it? Just look up.
I'll just post it again here.
Oh, okay.
Kareem, very impressive. Thank you.
Yeah, sure.
So presumably, Ray, if you're going to do data collection, you probably want to try to do it under contest competitions as much as you can, like out of doors after a good fix, and see what happens.
Yeah, I could maybe rent a room from Steve or something. Say, Steve, I need to stay here for a while. Yep.
Just take a picnic lunch. An hour or two's data collection ought to be enough.
Yep.
There is an intermittent base station up there. I haven't checked on it recently. It's in Princeton.
Yep.
And but it seemed to have, it went away for a while, but it seemed to have been back. But I haven't checked recently. But that would be an N-trip style base station, so you'd get your data over the internet.
When I was browsing around on this topic a while back, I was amazed at how many informal base stations there seem to be around, even up here in Southern Ontario.
Yeah.
Yeah, in some places the government steps in and sort of makes it a lot more accessible. Texas has decided to go the other route. So there, even though there's, state agency run base stations, they sell that data to commercial carriers who then make it available for pretty steep fees. But the RTK to go network is pretty nice, so I would recommend checking them out. It's a free service.
Yeah, it's kind of weird. The SparkFun examples, they have a couple examples to, how to set up a base station. He never included one to set up a rover. It's kind of like, well, okay, why not?
They're definitely out there. I'm 100% sure. I wouldn't say that the SparkFuns were necessarily the best ones, but there was a full write-up on, at least with the F9P, there was one. I'm pretty sure.
Yeah.
On how to set up a rover.
Yeah, the M8P is seems to have a lot of differences between the.
Did you get that a while back? Or
yeah.
That was actually, so basically the numbers in the series, the 8, 9, and the 10, those seem to be like generations. So it's when they actually go to new fab processes and things like that, which does indicate a series of new designs as well. But the F9s, the 9 ninth generation was a big step forward. The 8th was the first time they had the RTK timing down, but it looks like you can't even. It looks like those are legacy products now, the M8s.
Yeah.
And so now they have the 10s, but I haven't tried any of those.
Yeah, me neither.
But there's,
Right.
you have to be careful about which sub model you get, because
Right.
they're very different on the features. It's not that 8, 9, 10 tells you very little about the specific features that you're getting on a particular chip.
Ray,
Yeah,
if you're
there's several
Sorry, go ahead.
Neo M8Ps, but the Dash 2 was the one that, could do the in-survey mode, and some of the other ones, well, I think any of the other ones don't support it unless they have that Dash 2 on it.
The Dash 2 seems to be the one that supports both rovers and base stations.
Right.
So you should be okay, but I don't know anything about like the quality of the signal, if that's something that changed over the generations or not.
Mm-hmm.
Ray, if
Oh yeah, I'm sure they've made improvements all along, but
if your RTK GPS fails in competition, I'm curious, what is your fallback plan for navigation?
I think it falls back to 3D fixed, or yeah, not 3D fixed, just 3D.
Okay. So you'd go back to basically regular GPS
Yeah.
with 1 or 2 or 3 meter resolution.
Yeah. I don't know. I want to say it was.
Are you going to try any kind of short run inertial navigation?
No, I do have a BNO 055 on it, and I use that to and Dave Anderson's software to do basically azimuth, which is yaw.
Yeah.
And basically the meters to go, from where I am to what my, target latitude and longitude is. And I had that, called it my chick magnet, the thing that sat on my wrist that use ESP now to communicate, all those things. So I could just look at it and say, okay, well, it looks like it's, I could look at the fix, and I could look at how far it thought it needed to go to get to the target, and what angle it was seeing, and what the BNO, what compass heading it had.
Yes.
Yes. So
do you have odometry on your robot? And
yes.
In your past experience, have you found it to be dependable in outdoor uses?
Yeah, these were Tanner special motors that I actually picked up 2 of them when he was, his last few months of operation, and the encoder count, through the gearhead is very high. I think it's around 8,000 counts or so per revolution.
Sure.
And
I'm thinking in terms of wheel slippage on the ground and things like that. Do you find it?
Yeah. So, it only does, only does great if you don't have wheel slippage. Yeah. If you do have wheel slippage, then,
I just wondered if you had any real life experience in that. Past competitions.
Yeah. From, Steve's property, of course, any property in Texas, gets hot, and then, the ground dries up, and these, cracks that are big enough to, stick your foot in, open up all over the ground and stuff. And so there were a few times when my rear wheel on the rover basically locked itself into one of those cracks, and the wheels were just spinning, and it couldn't pull itself out.
Okay. Has anyone found that the weight of your robot makes a difference in terms of wheel slippage out of doors?
Yeah, probably the heavier you push down, there's probably a good weight to have to, you don't want it so heavy, but.
So Pat Carone will have a winner then.
It depends on so many things, right? The kind of terrain that you're on, it's vastly different. Loose soil, versus sand versus grass, bumpy
Yeah.
grass, the
Okay.
total roughness. There's just too many variables to say. You could probably say for a given robot, there's generally going to be a place where getting too light is going to be a problem, but getting too heavy can be a problem in a swamp too. So it's like I don't know how to characterize that.
My little first attempt at an outdoor robot is now kind of operational. So I had it outside a few days ago on bare concrete, and I'm seeing slippage. And I'm saying,
Absolutely.
"Oh, I didn't plan on that."
Yeah. So your tires are fairly hard then? They just skid on the concrete?
Yeah, they are, and the robot is very light. So
Yeah.
that's the other part of the problem.
This is one area where having a RTK solution is really, really nice, because what I do on this robot's no longer in existence, but I had a robot where I was doing what I called geoscribing, which was creating trails in the dirt and things like that according to patterns. And I've showed it on DPRG stuff previously. But the way I calibrated that, so I have an IMU in that as well.
Yes.
And what I would do is I would tell it to go straight using the IMU, but I wouldn't care about the distance. Right. So the IMU is responsible for keeping the robot straight, and it doesn't matter, like as long as it's tuned well enough, it will still do that regardless of the terrain.
Sure.
But the RTK would tell me how far I've gone. Right. So I'd tell it to go for a certain distance under RTK. And by the end of that, I would know what my odometry was for the ground that I was on.
Yes.
So
yes.
I would have a calibrated odometry, and my IMU would also would be aligned to the true direction. So I would basically reset my heading on the IMU, which starts out purely relative to the robot when you first initialize it, right? But then I could create an offset so that it would always mark my actual heading in like degrees, as you do with navigation.
Oh yeah, that reminded me. The magnetic declination that I had, I actually had it as like 2.5, positive 2.5. For Steve's area, it should have been -7. So I don't know where I pulled that number out of, but it's kind of like.
And how far apart are these two locations?
From where I live to where Steve lives, maybe 20 miles.
Boy, I'm really surprised at that.
Well, I think I don't know. Like I said,
that
I
had
don't
to
know
have
where I
been
got
an
that initial
aberration. Yeah.
reading, but I looked it up again, and it's like, well, yeah. Problem number 3, wrong magnetic.
A lot of iron in his ground, maybe.
What's that?
A lot of iron in the rocks in his ground.
Oh yeah, yeah. And we do have that here. There's I don't know, whatever kind of rock it is, but yeah, you'll come to areas where just holding a regular compass and it'll change. These are the wheels that I got. They're push mower, wheels off a lawnmower. They were
about a foot in diameter.
These I don't think are a foot.
That's pretty big.
I think they're 10 inches, just under 10.
Okay.
Yeah, like maybe 9.5 or so. They're the description I think says they're 10-inch wheels. It's kind of like, okay, when you washed them and they shrunk or something, what happened there? But yeah, they're a hard plastic. They do have pretty good cleats, I guess, but the center is like a solid line, and it'd probably be better if it didn't have that center line, if it was just a cleat across, and because it tends to ride on that center line a little bit and give you less traction.
Ray, do you have a feel for how much that weighs? Because I got a set of wheels, and they were almost 3 pounds a piece, and I was amazed. That was, I got another set of wheels that are around a pound, and that's a big difference. You know, just trying.
Yeah, I would say these are probably closer to a pound. I
And
don't have my.
how about the hub? Is the hub easy to connect to?
Yeah, it's 3/4 of an inch, so I could,
Yeah, you'll have to shim it probably.
well, I was just buying 3/4 inch, shafting that had that was keyed already,
Okay.
and drilling it out to it's the motor shafts for 10 millimeters. And so I basically made an adapter that went from 10 millimeters to 3/4 of an inch that was keyed. And let's see here. If I have one of those wheels off, I don't. Anyway, there are 3 holes here.
Yeah.
And I actually welded. Yeah, these ones were 1/2 inch, but I welded a sprocket that's keyed to, it's an electrical cover plate that was like 4 inches round. And then this bolted, I drilled the 3 holes on it. And where's the line up? It lines up like right like that in the center of it. And so this metal plate is bolted to the wheel, and then this shaft is keyed. So it's, it's not going to go anywhere or slip or whatever. So that tended to work pretty good on, a couple different platforms that I played around with.
I will say this, though, Tom, to your question. Dave Anderson's, I think it was called JBot. Is it JBot? Was
That's a 6-wheel.
when he started out and when he did his famous hat trick, he was only using odometry. Now, so that would suggest kind of that maybe those big soft tires, kind of balloony tires that he has, might have reduced his wheel slip, pretty good. I'm not saying he didn't slip. I'm sure he did, but because like Ray says, you hit something wrong, or when you just spin for a few seconds before you catch, there's a lot of things to throw it off. But he would tell you that what Kareem is doing is the way to go, or otherwise the biggest problem you have is angle, because you can be off just a little bit in the angle and really be off. But distance is usually not the big concern. It's the angle. So having a good way to figure your heading is probably important. Now, hey, Kareem, Ray, are you guys using the heading estimate from the GPS as part of your calculations, as well as your IMU value?
I am, yeah.
Yeah, no, I'm not. I was just using the BNO 055, the yaw.
Okay.
So once, you actually have to be moving before it becomes a relevant thing, right?
Yeah.
Right, and you have to have somewhat consistent movement. But like if you're doing rapid turns and things like that, then the data is gonna be strange. But yeah, so that's why I use the IMU for short-term readings. And then but I continuously recalibrate it according to the average long-term distances when I know that I've been going in a straight distance for a while. But yeah, so you can correlate between the two, and it doesn't. I probably should have been using something like a Kalman filter to do that, but there's still a bit of a mystery to me, quite honestly. Yeah, so I just like, I mean, there are easier ways to correlate the 2 signals that you're receiving. The problem is that the IMU can get off rapidly if you've hit a lot of vibration. And that I didn't have that problem with the heading coming from the GPS. But again, the GPS, it's only when you're moving, and to trust it, you need to have that good RTK fix.
Yeah, actually, I need to modify what I said. I get the azimuth from David's calculations, and I actually make that match up with the heading on the BNO 055. So if it tells me I need to go to whatever, 2 degrees, maybe clockwise, then I use the BNO and what it's reading to adjust until I get that. So, because the BNO it can respond very quickly. So, I think you can, I want to say you can go up to 100 hertz with the BNO 055.
I don't think
It's pretty fast. I don't know what the max is. It depends on your I2C data rate, I think.
Yeah, mine, I'm just using it at, like 20 hertz. And that,
That's sufficient. That's more than enough. Yeah.
Yeah. So, but yeah, that seemed to work out the best. I guess, yeah, you probably would get one really weird reading when you're stationary and you make your first move because there is no angle. So
yeah, you gotta have come to think of it, I might actually have had the benefit of Kalman filters, because the way I wrote my interface to the F9P was to basically use it as a GPS source for Android. So I wrote a program that publishes it as a high quality Android, and Android has a whole bunch of extra things in it for navigation. So it's quite possible that it was doing, well, it didn't have the IMU data. Did I give it the IMU? No, I didn't give it the IMU data. No, I was doing that completely separately. So I guess not. But I was basically, Android has a bunch of navigation API or a stack basically. And so that's where I was getting, I think that's where I was getting my heading from, not directly from the F9P. But it was based on the RTK data, RTK locations history.
Doug, have you experimented with pickox and Mission Planner and that kind of stuff?
I haven't. I have played with Mission Planner and the old Autopilot, which was pre-pickox, and yes, it works.
Mm-hmm.
Yeah, it works.
So you had
it's a little more laptop dependent than you probably want to be.
Oh.
And like when ideally in the contest, you'd like to take your robot up there, sit it down on the ground, flick the switch, and that's the last thing you have to do with it. With all of the other ones where you're using Mission Planner, you kind of have to get it kicked off and initiated with Mission Planner, and it's just a little awkward. I'm sure if you were, it can be done, but I can tell you that, those autopilots do work,
mm-hmm.
and even the old ones work, but you got to figure out how to handle. They're not real good. Otherwise, if you want to go from waypoint to waypoint to waypoint, they'll do that for you. But interrupting them and finding your cone and stopping and then re-engaging them and everything, it can be done, but it's not as simple as just going from waypoint to waypoint to waypoint. Going from waypoint to waypoint to waypoint is really fairly easy for those tools. But and I've never done a pickox because be quite honest, it was like trying to time the market. Like I wanted to get the Pickhawks that was like the final design. Well, when I finally decided that I might be the time, they don't call them Pickhawks anymore. They're something else. So I just, I don't know. Too many people have solved this problem the way we generally approach it, that I have to feel that I want to do it that way first.
Yeah.
And, I mean, I'll be quite honest, if you look I got 6 points once before by using an autopilot. And, I've also had an autopilot where, because I had some bug in my software, bloop, never started. I mean, you just stopped there at the starting line. So, I mean, there's been a kind of a mixed bag. But this year, I'm hoping to, I'd like it, like I say, I'm trying to figure out how to use a Kalman filter, but I got to be quite honest, that might be the long pole. I might not quite get there. It'll get there next year for sure, but this year it might not. You talk to people who use these, and apparently once you've got your head wrapped around it and you actually made one, they're not hard. And the concepts are really, when you read about the concepts and you can follow them along, and they're not hard. I mean, or at least, they're not hard to follow along. But then they start doing the math. And unless you really know your matrix math, you're going to get lost in it. Now, if you've read, I can't think of the guy's name, but the gentleman who has a Kalman filter tutorial on our website, I can't think of his name right this moment. If you look at what he did was he told you to run 3 filters. Essentially you run an X filter, a Y filter, and a home and a heading filter. Okay. So he says that way it's much simpler. The equations are much simpler because you're not trying to do it all in one big ball. You kind of make it little balls. But anyway, that's just an input.
I would be highly reliant on Chat GPT if I was going to go into figuring it out for sure.
Yeah.
Yeah, I found that kind of useful. I just, obscure things like I'm sure it's in the manual for the M8P somewhere, but I was using Chat GPT. It's like, I just ask a question and it came, pinpointed it amazingly quick and was the correct answer I was looking for. And it's like, wow.
I've been fixing one of my PCBs and, since I use KiCad, but I don't use it day to day. So, I always have to kind of like, okay, how do you do that again? Boy, that's when the AI really works great because, even if it doesn't hit it right on, it's enough to jog your memory. Oh, yeah, I remember now.
Yep.
Yeah. So,
pretty amazing.
Mm-hmm.
I've been using the 01 preview of ChatGPT, and it's better. It's a lot better in terms of the especially for things like code and anything that was really subject to hallucinations. It's not done by any stretch, but it's worth the extra delays you get. I don't know if it's available on the free version of ChatGPT yet.
Do you pay for ChatGPT? Don't you?
I do. Yeah. I find it useful.
Yeah, and do you think the the money, I guess you do. The money you're paying, you feel is
It's worth it.
giving better.
What is my time worth, right? It's like $20 a month. That's nothing for the amount of time that that tool can save me.
Mhm.
Not every action leads to a time saving. Sometimes it's costs, but on net, I find it's a time saving, and I think of it more as a personal tutor and sounding board as much as anything. And it's not like it's going to give me a deeply thought out solution. But it's pretty powerful what it can do. We got to adapt. It's a tool that's here to stay, and it's like anybody who's looking for work in anything technical these days. If you don't have it, you're basically a dinosaur.
Kareem, do you find yourself using just asking the 01 preview, or do you start off on the regular 4.0?
I've switched to the 01 preview, because even if you have to wait a little bit for your answer, that's time that I'm probably still thinking about what I wrote as my prompt, and it's like it's worth the wait because of the I think I don't know how to characterize. I don't have enough. I've only been using it for a couple of weeks. It hasn't been out long, so I don't really have good data on like how much. What is saving me is partly on the quality of the initial answer, and definitely more trust in and not wasting time and going down false paths. I've still gone down false paths with it. It doesn't know everything by a long shot, but it's definitely improved. So I'm happy with it. Yes, I will wait the extra time for the return of the prompt of the answer.
All right. And however many extra gallons of water does it take to answer your prompt, doesn't matter.
Yeah, it's that's a whole other thing about the amount of energy these things are consuming. Yeah. But to be yes, this is far from an excuse, but I'm sure I could save more if I just turn my thermostat up 1 degree.
But it's not happening in Texas.
But it's like
that affects your productivity too, I'll bet.
It does, yeah. Yeah.
Yep. It's like having a very patient friend, It's like, hey.
And you rarely get a snarky answer.
Very rarely, yeah. You got to ask for one to get one.
And then it'll deliver.
Oh, will it? Huh.
Yeah.
Tried that.
Handily. Yeah. Just ask it to generate code in the style of Dr. Evil or something like that. It's phrase your response as if you were, I don't know, Rodney Dangerfield. Okay, so we've had quite a healthy discussion for the last hour or so, and we did have a queue, and I didn't want to forget. Next in line, we had Kareem, Tom, John K, and I had something to show actually, as it turns out. So, Kareem, have we managed to touch on what you're going to touch on in that, or?
No,
that wasn't what I was going to talk
It's
about.
All right.
Scale of woe with Raspberry Pis, right?
Anybody recognize this flashing right here?
Nope.
Right there.
Is it beeping at the same time?
No, I'm not hearing anything.
There's not a
But
tick or anything like
it's
it's
a
about to
boot.
explode?
It's a boot flash code.
Okay.
So this is a stack up of a Raspberry Pi right here. This is a NVMe board on top. But yeah, this was working fine until I ran a setup script for the product that it's mounted on. And I should have interrogated it a little bit more deeply. So yeah, now it's not booting. But this is a Wave Rover that I posted some stuff about. I posted a link to it in like ready to go kits or something like that on the Discord a while back. And I'm having fun playing with it, but yeah, I did kind of crash it. I can give you a little bit more info about it if you guys want, but I can save that for another time also. It's up to you guys.
Yeah.
I see a power cord coming out of that. Is that because you're charging its internal battery, or you're running it off a wire?
Yeah, there's the power cord. So there is a battery. Well, since you had a question, I'll go ahead and show a little bit more information about it.
I ask because I'm used to running my robot in development here from the 5 volts on the USB cord that goes to the computer. But I've added so much stuff now that 5 volt from the USB cord drops down so far that I'm getting brownout dropouts on the micro. So I have to run the robot with the battery. And I never planned to charge the battery when it was in use. I'll be changing batteries more often, I think.
Now, where did I put that window? I got about 30 Chrome browsers open.
They multiply.
They do.
And then they hide.
Okay, so this is the product as you get it. You see the screen.
Yep.
So I'm just going to sort of zip through. Power adapter. The robot comes pre-assembled. This is just the unboxing. That's the bit that you get in it. Just zipping through. I think what I'm pointing out here is that so this will end up being a video, but these wheels seem to be hollow rubber. Doesn't seem to be any foam in them, but they can support the weight of the robot fine, plus a little bit of a load. This is looking at it from the top, and the what you can see right here are some headers sticking out. So that's for attaching a Raspberry Pi or extra peripherals to. But there's an onboard controller inside this unit as well. So this is, I'm opening it up here. You can see that there's basically 4 different hub motors. This is the lowest end of the rovers that WaveShare produces, sort of in this line. But so here I'm just showing where the wheels attach. Let's see.
Is that like a $200?
This is $100.
$100. Okay.
This whole thing costs $100 as it is right here. So these are there's tiny little motors inside.
Yeah.
Gear motors. They're actually 12 volts, 200 to 1. They're mounted directly to the gear output shaft, which is not a thing I like, but so don't step on it. But it's again, for $100, it's pretty decent. This is the battery bay. It takes 326. What are they?
650s.
650s.
18650s. Yes. Let's see. Taking off the plexi shield. So this is what you get inside. So there's a motor driver board here attached to a power conditioning board. So this is the battery charging circuit, and it provides power to this board. And I'll talk more about that board in a second. But that one's doing all the low-level control. So it does the control for the motors on this robot. And by the way, and it's ESP32 based. So you can also it comes ready to go with like a remote control interface that you can connect to over Wi-Fi. Let's see, do I need to show anything else in here? Probably not. Before I recognized that I didn't have 18650 batteries, I tried putting in another battery, other batteries that I had. Yeah, they're slightly longer.
What's wrong with this picture?
Yeah, exactly. Just if I press a little harder.
Yeah.
Yeah,
Where's my shoehorn?
exactly. So I got a document. I posted this document as a link on the Discord under member projects. So this is sort of my notes as I have so far. That goes into some more detail about this. So that's available. My plan is to. I'm looking at this as a low-end, entry-level mobile ROS 2 platform. That's my goal behind this. And I'm starting to work on a presentation for it. So to just give you some context, this is the product that we're talking about, and the Wave Rover. The $89 is the price from China, but the shipping is actually higher. On Amazon right now, or as of like a couple days ago, this was $100, and that's where I got mine. They have so there are 4 motors. Each motor has its own driver for it, but there's no odometry on these. There's no encoders on this one. You go up to these models right here. They all have encoders on the wheels. These models right here, these two. So this is also a 4-wheel kit, and so this is called the Rasp Rover. So what they do is they sell it with the Raspberry Pi. Already bundled and pre-configured and loaded with their custom software. But their software is available open source, so it's available from anywhere. And then they have models that have like a pan tilt camera on it as well. There's also an audio on these two. There's an audio board as well, so you can give it text to speech and stuff like that. They also have like kits for arms and there's some other cute little extensions, but I don't have them all loaded in memory right now. But what these all use is a driver board. So there's actually 2 different models of driver boards. So this one is probably the worst product name I've ever heard. It's so generic, but general driver for robots. But it's pretty amazing what you get for the price. So they also sell this separately from the robot. So they cost $28. It's the same price that I found on Amazon. So if I've already got Prime shipping for free, so doesn't cost me anything extra there. And but it's an ESP32. So that means it has Wi-Fi, ESP Now. It can so there's these 2 40-pin headers right here. Oops. So let's look at the other side of this one. You can't really tell, but this one, the one to the inside, is basically what you attach the Raspberry Pi to. So this actually is a hat, but it's on these robots, it's at the bottom, so I guess the stack is a little bit upside down. So you mount to this one, and then they extend all of those GPIO pins over to another one, so you can have access to it as well. And so it's got 4 open loop motor driver ports. These 2 ports right here are motor drivers with a quadrature encoder on them. So if you have these driving the wheels, then you still got 2 more motor drivers. You've got this is these right here are for their flavor of serial bus servos. And there's an I2C port, there's a LiDAR port, and there's the power supply right there. There's 2 USB-Cs. So one of them is sort of your interface to the controller from like a desktop or laptop. The other one, if you have their flavor of LiDAR attached here, then this will be spitting out the LiDAR data, this other USB-C. There's a built-in 9-axis IMU. On this one, there's a micro SD slot on the backside, and they can deal with a 9 to 12 volt voltage range. So it seems like an awful. So in some ways, this is the worst name you can imagine. In some ways, it's entirely accurate. It is a general driver. Like I could imagine sort of basing a fleet of small robots off of this, because just it provides most of the stuff that you might need right out of the box, it seems. So there's a variant of this board that ships with these three right here, and this is also a bad product name because it implies robot operating system. It kind of means that, but it doesn't. So anyhow, the differences of this one relative to the previous one is that basically the 4 motor ports are now called switches, but I think that they still give you a variable output. So I don't know that there's a huge difference there. But it has another 2 motor ports with encoders on it. So you can run 4 with odometry. And it has an extra I2C connector, but you give up the micro SD slot. But I think the odometry is for a 4-wheel drive is probably worth it for most of the platforms that they have it bundled with. I have some data on the servos, but I don't think I need to go into that right now. But just I became aware. The main thing I'd say here is I became aware that there's sort of 2 different brands of servo, of serial servo that aren't like the really high-end type you'll find in professional robotics, but there's either there's the High Wonders, I think they used to be called Lewinsoul. They produce serial bus servos as well. They have a slightly different protocol. They have different pinouts on the wires. I've seen evidence that you can make the serial ports on these driver boards work. The serial servo ports on these work with the High Wonder servos, but the WaveShare servos actually are a little bit nicer. Like the High Wonders typically go to, I think, 240 degrees of movement, whereas these are these can switch dynamically between servo and continuous rotation mode. They can do a full 360 degrees. They have acceleration control, and they might also have torque control. So that's a lot to get in, a $28 servo.
That's a lot of torque on a servo. Wow.
Yeah, the digital servos these days are pretty amazing on how much torque that they can do. The place that they tend to fail the most is in the gearbox. So if they receive a hard shock, then that's the place where you have to sort of really be worried. So I'm early in the process of activating this whole thing. I would say I'm pretty impressed with these are the so here's the driver board, the general one, and its product page, and it's pretty in depth of just what it has, and then they've got a wiki behind it, and the wiki gives you all of the details, including circuit diagram's not super complete. I'm still trying to sort of grok, I guess, the totality of all of that information. But there's a lot of data on this thing. And then there's also their open source, should point out in this document, I've got a list down here of, where is that? Yeah, so this is their this is their GitHub presence, if you like. So this these two are basically the firmware for those two boards. So you have direct access to it, and you can change it. And then this is an example of using it from a Raspberry Pi. So basically they have this serial API that you use to control the lower end, what they call the lower board, and it's the. Do I have something on that in here? I haven't written all that up, but basically there's a JSON API that with a bunch of commands for controlling all of the different peripherals on that board, so that you can just send it, basically a serial packet. You can send it over a serial link. It seems you can send it over I2C. You can send it over, there's a web interface, or over ESP now. So all of those methods are available. So this one right here, again, just gives you an example of how to do that. And built into it, there's this tutorial section right here. And there's a whole bunch of, basically you got an interactive Jupyter lab as well. So here you're programming these things in Python. And so they come with the full information of basically documentation combined with code examples that you can just run. So if you're in Jupyter Lab, there's a little button here where you can just hit play and it'll run the example. And yet, so my one caution today is that I was doing the I guess it was probably the README on this. Back to the. Yeah, I was following the setup guides, and this setup script, this was all bad on me, right? He says that you can use this tutorial to install this program on a pure Raspberry Pi OS. Well, I had Ubuntu loaded. And let's just say that it didn't play nice. So the sources changed to some Chinese repository. So I've got a scrambled mess that's some combination of Ubuntu and the latest Raspberry Pi OS. And so I need to go back to square one and reload everything. Anyhow, that's my story, and I'm sticking with it.
I admit, thank you for showing us that. I know it wasn't on this schedule. I have to admit, I'm looking at that general driver for robots.
Yeah.
And that, I mean, basically the functionality and even the ESP32 is almost identical to what I'm building piecemeal on my robot. Maybe I know where to get the code from now.
Yeah.
Good Lord, thank you.
That's a lot of work. Yeah, they've definitely put a lot of work into that. But it's remarkable how few like tutorials are out there outside of their stuff. But their stuff seems pretty complete. But I can't like truly advocate for it because I haven't successfully been through the full thing. Although. Well, it probably won't work. It wouldn't work right now, but I have had this thing tooling around the house under remote control from my phone and from my laptop.
Did the motors seem a little underpowered for their size, or?
They're given that the platform is so light and small, they're actually just fine. Way under what I have experience normally with. But given that they're also 12 volts, the current isn't as bad as I would have expected. And so, yeah, they're not like high amperage motors, for this platform, it zips around. There's some speed rating that they have. I think they said something like, I think it was about 7 feet per second or something like that in the fastest mode. This is open loop, so it's just voltage control on the motors on this version of it. But it's zippy enough. The motors on the 6-wheel. Oh, by the way, those 6-wheel ones still only have 4-driven motors and 4-driven wheels. So the wheels in the center are just idlers. Basically, they're just helping support the platform. But it is, you'll notice the wheels were all the same, I think. It is definitely a larger platform, and the motors on that, again, they have encoders, but they're also beefier, and it looked like they had about 3 times the power of these. And so that platform also has some mounting rails on it, and those larger ones, they call them the UGVs, and so they're designed to accept somewhat heavier accessories, and they have a bigger platform on which you can mount everything. That's all I was going to talk about.
Pretty cool. Pretty cool.
Nice little toy. Oh, so that's an RP LiDAR C1, and so one other caution is that, so for example, this connection right here, while there is a LiDAR on the board that's in here, there's a LiDAR interface. It is not physically compatible with the C1, the RP LiDARs, and it turns out Waveshare also sells their own LiDAR. So everything, so like they have their own brand of servos that are slightly less, they're not compatible with everything else, and they have their own brand of LiDAR, which seems to have its own flavor. And I would be 100% sure that this could be made to work. The RP LiDAR could be made to work with the right adapter cable and changes to the software. Well, not 100%, but I'm pretty sure. So they have this open closed. It's not a walled garden, but it's sort of wanting to be that way, I guess. I don't know. I guess they have a right to optimize for the products that they sell.
It's appropriately set up from a marketing point of view so they can make some money.
Yes, exactly. And there's nothing wrong with that, because they wouldn't exist if they weren't. So, yeah.
Okay, then cool. I think Tom, you were next, then John and I, and then open mic.
Sure. Just a couple of hopefully quick things. I had mentioned a week or so ago of my interesting trials at attempting to measure pulses accurately in MicroPython on an ESP32, and said I would give up on that, and I converted my interface computer, the interface box that converts the pulse width modulation signals from the radio control receiver, are now converted into a serial UART stream. It's running at 57.6 kbaud, 6 bytes per packet per frame, and it's working very, very well. The UART hardware functions on MicroPython on the ESP32 work exactly as we would expect them to, and that's really good to hear. Now for the little bit of bad news, and another one of the trials of MicroPython, the documentation of the UART drivers for MicroPython, at least for the ESP32, are not as advertised. Many of the parameters not only do not do anything, but they will crash the interpreter. And once I started to Google this thing, I realized there were some other people complaining of the same problem. And the way you solve it is, I prefer to explicitly identify all the parameters available when I call a driver. That just makes sense to me. It's good documentation, and it ensures everything is the way I expect it to be. And that will crash the interpreter if you do that according to the documentation. So you begin to remove them one at a time until your driver stops crashing. And by the time you've gotten rid of them, you've gotten rid of about half the parameters, because half of them don't work. So anyway, it is working, and it's working very, very well, and I'm quite happy with that. So I've now been able to take what started out in a thrift shop as a really cheap radio controlled toy truck powered by one of these to a substantially more complex and expensive radio controlled toy truck powered by one of these. But it does work very nicely outside and very reliably. And it now goes through a very complex single board computer digital interface. So that's a major step forward in terms of having some manual control, being able to test a bunch of other stuff, having a fail-safe for an outdoor robot. So I'm pretty happy with that. The UART driver problems were a bit of a surprise. But on to the next step. And the next item was my efforts starting a few days ago to take the very simple low-resolution wheel encoder I built into one of the wheel hubs and bring those pulses into the ESP32. And I had read in the ESP32 technical manual about this fabulous block of 8 hardware quadrature encoder counters. Just incredible stuff. Really, really good thing. I've never seen anything like it built into a microcomputer. And then I read in the MicroPython documentation that they have implemented the counter drivers for these 8 objects in MicroPython, and it's been floating around in the documentation for a couple of years. They implemented a subset of it. It's not quadrature encoding, it's just single phase encoding, but that's all I've got. So I'm really enthusiastic, and I've got all kinds of plans to use this stuff, except it's not actually implemented. And once you start to look into it, you find out that people have been complaining or, well, looking for it for years. I finally read enough in the official MicroPython forum sections where some of the major developers talked about how difficult this has been, how low priority it's been, but they did provide a link to their work in progress. They have a GitHub from one of the major developers where he documents the work he's done to implement a number of the hardware peripherals on the ESP32 in MicroPython. And that's kind of cool because not only is the unfinished code there, but there's a README file that talks a lot about the implementation details and says, basically, we're sorry we haven't got this to work, but here's some non-driver code you can use. So I'm using his non-driver code, interrupt-driven stuff using the software.
So Tom,
yeah, go.
I'm a bit floored, Tom. You're meaning to tell me that somewhere, something off the internet that claims to work doesn't. I'm floored, man.
Well, Harold, here I am wanting to believe all these highly reliable people working on this incredible language, encouraged to use it by multiple other people. And I admit, I'm being a little naive about this.
You're preaching to the choir there, brother. I'm just telling you, man.
Well,
So,
I got the choir robes on. I sing tenor. So, I'm ready to go. So
it reinforces the need to test and test and test. So anyway, I will be able to get this low resolution thing working using the software interrupt structures. I've got it working already and it looks okay. But I admit I am disappointed because that hardware block looks incredible. I also have to admit that earlier today, I dug out another one of the ESP32s that I have configured in an expansion board, and I started to program it in C. I verified, for example, that the counter blocks are implemented on GitHub with driver packages that will run in the Arduino version of the ESP32 board system. And I have some of that running as of this afternoon. So Plan B is beginning to appear. We'll see.
I was going to say you look at GitHub sometimes and the last date that something was touched was, 4 years ago. I don't know if you just experienced that, but it's like,
the GitHub on the ESP32 MicroPython development stuff is 3 weeks ago.
Oh, wow. That's really.
Yeah. Wow. Now, some of the stuff in there is 8 years old, but some of it's also 3 weeks old. So
wow.
I wasn't going to go through it and try and figure out what was what. Once I went through the README, which was actually from a developer's point of view, very nicely put together, but it basically says, no, it doesn't work. And here's a fallback plan. So, okay, well, that's good. I can use that.
Yeah.
Anyway, that was it.
Very nice. Repurposed RC car truck thing. Okay. John K., what you got?
Okay. So I found this. I need to click on something before I click there, though. Oh, share. Where's share? No. Present. No, that sounds right. And then we want a tab. A tab to share. Okay, I think that's it. Yeah. So, found this. So if you need a server, in other words, there's some restaurant around here that has, let's like something like this, but what really caught my eye was the fact that they had a little bar up here that said hello and whatnot. And then they train, let's see what else, that's bigger, stronger, and smarter. Well, it was sort of interesting to lay out the base thing. Notice a sensor there in the front.
Multiple languages.
Yes, well, it's for everywhere. So yeah.
Yeah.
It's
Yep.
trains 100% self-driving.
Yeah.
Narrow spaces. Some patents.
That's
zero
enough beer
tolerance.
over.
So yeah.
Yeah, I saw one of these being in Key West last time I went down to visit my parents. They were using one of these in the Japanese restaurant as a busboy. So they stick all the dirty dishes on it and tell it to go back to the kitchen, apparently. So
Trains that can carry 88 pounds.
If you like sushi, and there's Kura, Kura, it's sushi on a belt. There's a couple locations up in Plano and Frisco, and basically it's a little bit different model, but that's what delivers your drinks to you. So they got a thing where you can say, okay, here's the sushi going around on a belt, but if you want something special, it's got a second level belt where you can order something up and it'll zip it out to you. And then if you order a drink or something, like, hey, I need more soda or tea or whatever it is, in just a few minutes, some human over at the drink stand has loaded up your order, and you have a little robot coming over beeping at you and saying, here's your drink. You know, if you'd like to experience it anywhere near in the DFW area, I know those things exist there. So
Here's a picture if you want a nightmare of all the robots running down the hallway.
I was gonna say that that restaurant's money laundering because those things aren't that cheap.
Well, somewhere I know it's on the link that got me to here. It was something about like $20 a day on their cheap end. So who knows, how much it really sells for in that. But
100 years from now, we'll still be using robots to fetch me a beer, right?
so yeah,
It's
but there's this sort of dimensions.
They'll find out that that's what they were the most useful at.
at the end of it all. Forget the self-driving stuff. It's fetched me a drink.
Yeah.
I don't want to get out of the easy chair.
So and then they have accessory
Options.
call bell. I don't know what that would be. Okay. Oh, door opener. When that can't open the door itself, it was light. Yeah. So I guess they have a button so that I guess it comes to you if you push the button. I guess that's what the call bell is. So anyway, I thought it was interesting though, mainly the fact that they had a little wrap around display thing, and of course the sensors in the front there. At least that's what it looks like to me right there. So anyway, so this was a sort of interesting thing that yes, you can in theory buy one out there. So that's all I have.
Cool. Okay, now we just need one that prints money. Okay, so I don't have one that prints money or serves food or drink, but I do have this thing showed up in Tom's Hardware. So shout out if you've already seen it. But it just looked like an interesting kind of a board. If my computer ever catches up with me, I'll share it. There we go. Yeah, so based on the RP2350, it's this cute little board that's got drivers for 4 motors, outputs for 8 servos, and all neatly self-contained in there. Raspberry Pi. And Grove connectors. So it's already connectorized. Test points, buttons, lights. $25.
Yeah, that's not bad. Cytron does seem to produce some pretty cost-effective boards.
Yeah.
Yeah.
And if you like purple, there's your board.
Yeah.
So, anyhow, that's all I've got. I've been roaming around so much lately. No chance to do robots. Although I do hope to make a very low bar. I hope to just kind of eke over it for November. So we'll see. I might drag a toe, even though it's a few inches off the ground, but I hope to do it.
Drag a toe. What does
Well,
that
I mean,
mean?
some people jump over high hurdles, right? They set really high targets.
Oh,
I'm gonna have a bar just an inch or two off the ground, and my foot might drag on it as it
might
goes
still
over.
hit it.
But I hope to show up with something more than a participation trophy. We'll see.
I guess there's no need to talk about dragging things over the bar in the Olympics that had that fail.
Yeah, that's not the model I had in mind, but it could work. Yeah, this is the right audience to laugh at something like that. Yeah, since many of us are still stuck in the teenage years, that's good. Yeah, so totally open mic, as if none of the other meeting was open mic. So what else do we have for the night?
I was kind of curious, Doug, how are you making any progress with the A010, the distance camera?
Ray, I got to the point where I think that it's usable, you know what I mean? So I'm moving to trying to get my code base, and which I got to admit, I'm struggling. I'm a little floundering around in it. You know, like I say, God damn, I was smart back then. But anyway, we'll see. Anyway, I'm trying to get through that. And, but the sensor itself, I feel pretty comfortable with it. Enough to put it on my sensor list of my robot. It's going to, it's a little redundant with all the other stuff that's on it, but I just kind of like the way it works. We'll see.
So what are you interfacing it to?
It has its own serial port. So
Okay, but what are you hooking up to that serial port?
probably a teensy.
Oh, okay.
All right. Because what you do is you get an array of data,
Yep.
which, if I remember right, is 625
Bytes.
bytes, you know.
Yeah.
So
25 by 25.
Yeah. So you take that and do what you want with it.
Oh, okay.
Yeah.
So no issues with framing and that kind of stuff?
Well, right now, I got to admit I'm using Python, so MicroPython. So I got to say, I don't know if it will be when I start moving over to the Teensy, because that will not be MicroPython. That'll be C.
See, yeah.
Yeah.
Yep.
So we'll just see. You know, who knows? Maybe this guy will interface with the ESP32 board that I'm going to have for the ESP32 now. I might
Yep.
just throw this functionality onto that board. So that would probably be the easiest way to go with it.
Yeah.
Because
Okay.
I'm going to have one there anyway, like I say, to communicate. And
Yeah.
so I might as well do that. Like I say, that I got to admit, it is on the bottom of the list of the things I would like to put in. So I've got to get, somebody told me, well, Doug, you could make progress on your Kalman filter, or you could do that. I'd probably go with a Kalman filter.
Really?
Yeah, if I could, because I feel like, I always feel like it's just a little bit, just a little more, and I could get it. But we'll see. I do have to go. I am working my way through my code base, and it's C, and next year I think I want to convert it to C++. It just because you can, by using essentially what's the word for it? Struts, pointers to struts, and functions you can emulate a lot of the class information, and that's what I'm doing now. I'd like to go, but I'd like to I think it would be cleaner looking if it was in C++. So, but like I say, that's not going to happen this year for sure. So we'll see how it goes. Lots of stuff, and time is running out. You figure you need to really, really have wheels on the ground doing stuff by the end of September, because then you got to have October to test.
To make it work.
Yeah, make it work. Yeah.
Get off first base or the first cone, huh?
Yeah. So like I say, on this, I'm sure this is occurring with a lot of people right now. We're going to, they ask, well, what are you doing? What's been doing this week? Everybody goes, not much. Well, actually, what's going behind the screens is they're trying to get their robot ready.
It's the hustle.
Yeah.
Yeah.
So we'll see.
Yeah, I had.
Oh, I did get one kind of interesting idea. Let me see if I've got it over here.
And Doug Cream has a question for you before you.
Okay. Well, all right. Let me see if I can find this thing I wanted to show you. Might not be able to find it. All right. I'll be right back. Give me a second.
Okay.
Okay, I'm back. Let's first ask Kareem's question. Kareem, what you got?
Just based on our previous discussion where I was describing my my calibration of an outdoor robot with RTK.
Yes.
And then applying that to the no GPS portion of the rules. My question is, if I do that calibration process, I get an RTK fix before running, I figure out my robot's location, I figure out the heading with respect to true north, then I kill the GPS. What's the situation there? Is that eligible for the no GPS rule? Because at that point, while it's running, it will have no GPS.
Otherwise, you just want to have the GPS to initiate your starting.
Calibrate the outdoor odometry and initial heading.
On the course?
Yeah, or just outside the course.
But you know,
On the property.
on the property in the practice area, you can do whatever you want. You know, so if that answers your question, you know, it would be probably nice if one of you guys that did have a working RTK, you know, who could go up to the starting line and go ahead and say, okay, guys, this is what the starting line position is. Yeah, that would be nice. But we could do this with, I guess we could do that as, in the past, we've never really given people the coordinates for the starting line because we just figured, well, it's next to the home cone, so that's close enough. But I don't know if that would be enough for somebody trying to get. Here's the problem, okay? I think you should be able to do a single cone with no GPS because you can point it at it and go. All right. And technically once you touch the other cone, you could come back. So you could get 6 points, but that's not 9. You have to have 9 to get the no GPS award. So the problem is there's going to be a cone you don't know where it is.
No,
So-
I know that. There's no that's a different.
Okay, so maybe I'm misunderstanding what the thing is. Can you do what you want to do from the practice area?
Depends on where the practice area is.
Yeah.
It'll probably be over there.
Like how close is it right in front of the house on that steep part of the lawn, or is it
Probably.
which is totally different kind of ground because it's watered? You know.
Well, there's 2 places that I could. If you need a flat piece of ground, you could go.
Well, to calibrate for the kind of terrain that the robots will be on.
Well, that's going to be on a hill, right?
It's a much more gradual hill than the really steep part that has watered grass on it.
Okay, well,
It's the unpractical practice area, I guess.
It's all right. I was just trying to niggle you about the rules. It's not.
yeah, no.
It's about a rule interpretation thing.
Yeah, I would say if you're in the practice area, you should have no issue. But once you hit the starting line, you should be no GPS.
So partly what I was talking about is like, we know the GPS locations of the cones, right?
You won't if you're in the no GPS.
No, I get that, but we will approximately know that. But wait, you'll still know it, even if you're in a no GPS, because you've published them.
Yeah,
right?
Yeah, you will, but you're not. But when you run the run, your software cannot have any waypoints set in it.
Is that the no waypoint rule or the no GPS rule?
Oh, I see what you're saying. No, you're right. You'll know where they are.
So you'll know where they are. So now you turn off your GPS, but you know where you started pointing and you have pretty good odometry for the terrain at hand, right? If it's calibrated. So I'll still use lat long for the locations of the cones, but it'll be pure odometry to get there. So basically my coordinate frame for the robot is just true Earth coordinates. But that's just my local frame for the robot. There'll be no active GPS while it's running.
Mm-hmm. Yeah, so this would be.
Is that no GPS?
No GPS is no GPS. But if you just go in the no GPS one, you do know where that you have three waypoints.
Yeah, and I can convert them from their GPS. If I wanted to make it robot relative, I could convert them into just direction vectors and distances.
Right. Yes. So, I mean,
does it qualify as no GPS under your rules? That's all I'm asking.
I guess I'm not understanding the question. Like I say, when you hit the start line, you have no GPS and you have 3 waypoints.
Yep.
Okay. And there you go.
No, but what he did was basically convert it from one unit into some other unit called distance or whatever, or better angles. Yes, if you
Right.
make it into trigonometry.
Like they,
math.
like they say,
Yeah.
you know, Kareem, you know, when you're there you are. So
It's all right. I probably won't even show up to the damn thing.
yeah. No,
So if
My
you hit a
my
cone,
my team season is underway, and it's like all of that jazz too.
yeah.
so were you like once you hit a cone, are you gonna like assume that the cone position is accurate and you're gonna recalibrate off that?
Okay.
No, the rules say that the cone is in the general vicinity of the given coordinate within
All right.
something like 10 feet or something like that,
Right.
or
Realistically, that's because we can't, we'll give you the coordinate of the cone. Usually that's what we do. But we can't guarantee that coordinate is not in whatever 10 feet or a yard, 10 yards or whatever it is, because that's the standard accuracy of GPS. All right.
they recorded the phone's location without RTK.
Right. Exactly.
Yeah.
So, yeah, and it's actually probably better because the phone also uses the towers and everything else. So it's probably pretty good. If you read the cones strictly, read the rules strictly, you're right. It's like a golf course. You have a green, and anywhere in the green, the cone could be. But you have, if you get within 10 yards of the cone, you get a point. So, like I say, because of, we didn't want somebody to say, oh my God, you told me it was here and it's really 3 yards over there, because, we were using a phone and to get the coordinates.
It was actually pretty accurate last time I ran. I actually ran right over the cone.
Right. Yeah. So I'm saying they should be, because like I say, the phones are pretty good, and they're using, what do they call it? The tower assist. So, I mean, I wouldn't be surprised if it's right on, but that part of the rule is really to give us some wiggle room so that if we give you a coordinate and it's a yard off, it's still good, But
It's still like the Monty Python thing, I fart in your general direction.
So, yeah, you're right. My first thought is odometry probably would be the primary tool. And, but again, it's kind of like hand grenades. If you're using vision, all you have to do is get close enough to see it. And so, if you get close enough to see it, then you should be able to drive to it. And if you know the cone location, you should be able to, do your not touching the cone exercise, whatever that is. Usually it's a back up and rotate. You can then say, okay, if I were really at the cone, this is where I would be, and you could zero out all your odometry and start over again. So I don't know. I think it's doable. Like I say, and then again, like I say, with the right filter, probably be even more doable.
Why?
So, yeah.
I was going to say it's hard enough with, kind of just regular GPS and, slippage to, kind of stay on track or on course. But so
Yep.
you're going to try that, but you may try that with just odometry, huh?
Yeah. But if you get, I'd have to look at the rules, but you're given 3 waypoints, So
So you know where the cones are relative to each other.
yeah, you know where they are, and you can't go in a straight line to any of them. So you're going to have some sort of obstacle avoidance, I believe, to go around them. But like I say, it's also, most of the vision systems can see a cone at 30 or 40 yards. So you get within 30 or 40 yards, you might be able to just drive to the cone once you get it in view. So I don't know. It wasn't meant to be easy. It was meant, that's why we, when you get 9 points using multiple waypoints, everything that you can, that's called a perfect score. And then the other ones are called challenges. And so they're harder. So anyway, I wanted to show, if you guys will pin me, I'll see how this works. Wanted to show you. Good. All right. This is this is the platform that I'm looking at. The wheels may change, but you can see it's right now, it's just the belt drive, and you can see this one happens to be pretty loose. Okay, so I could tighten it up, but I wanted to install a tensioner. So I've been struggling with this idea, just how I'm going to 3D print it. But then I saw something and I said, that might work. It's called a mousetrap. It's a
torsion spring. It's a great way to go.
And it turns out it fits real good. So,
all you need is a dead mouse.
Put a little pulley on it and have it rubbing up against the belt. It just might work. So anyway.
Yeah, GoBuilda makes tensioners. I'm sure Rev does too, right?
Sure
Rev doesn't make a specific tensioner.
They don't. Okay. No. I would think everybody did.
Yeah, so
I'm using GoBuildas.
I'm going to see how this works, because I was the spring that I wanted to use. I had looked at various options in different places and ended up with bunches of little springs, but none of them really didn't really look like they would be that good of a solution. But this, whatever brand crap this is, Victor, it's a Victor. The spring isn't like excessive. I want to say that on I can't remember the name of the ones, but the ones that got the wooden base, those guys,
those are tough.
They got a spring.
That's a break your finger spring. Huh?
Yeah, right. So this might be a good solution. We'll see. It might not work.
You don't necessarily have to have spring tension, do you? I mean, you could have just a fixed tensioner.
Yeah, that was my original plan, was to have a post and then but
down. Yeah.
But the real problem is, where I think the problem is going to be is, I can also tighten up the belts before a run. I think the problem is that during the run, you might get something that gets loose. So I wanted a more dynamic tensioner. We'll see. Like I say, it's an idea. I saw that the other day and I said, that might work. So anyway, that's just a little idea that I had. You can unpin me now.